I am Jeff McVeigh. I am responsible for Intel's supercompute business. Oh, we're so excited. We have products in the market now. Our Max series, which covers both our highest end CPUs, Xeon Max, as well as our Max series GPUs, formerly known as Ponte Vecchio. You bring those together with a unified programming model of one API, and we really maximize performance and maximize the possibilities for our customers. First one on the Max CPU, which is our Sapphire Rapids. Now we bring together that with our high bandwidth memory. So for years, compute has been advancing on CPUs, but we haven't been feeding it with enough memory bandwidth. And it's not just us, but the entire industry. So we've decided to bring this together and really advance and balance out the system with both compute and memory bandwidth. And workloads like molecular dynamics and manufacturing and Earth system modeling are all significantly improved by this. 2, 3, 4 times more performance than prior generations. So this is going to give our customers amazing value, amazing performance, and really help to solve those most important challenges the world faces. Well, HPC is critical for so much of our everyday lives. Many people don't understand how it really impacts it, but helping with climate change, finding new materials, new drug discovery, helping us really understand and model the world, model different devices, and then come up with new solutions for those. So that's why it's important to bring both our CPU, the Max series capabilities with the advanced high bandwidth memory, as well as the GPU. Now the GPU is another area that we've been talking about for a while, and now Intel has a full breadth from our consumer new devices for gamers, our Flex series GPUs for lower power, AI inference, media delivery, and now the Max series. And the Max series really turns up the capabilities, the performance to go after the highest end accelerated and the densest compute. And then what's really important here is how do you really realize that performance? It's not just the specs in those individual products, but how do workloads, how do applications become optimized? And we've been working on layers of one API, common programming model, common set of language support, libraries, supporting across CPU, GPU, as well as other vendors, so that people aren't locked in, and this really adds a lot of value to our customers. Yeah, the Max name is showcasing that this is the highest end that Intel has to offer across our CPU and GPU. Maximized memory bandwidth, maximized dense compute, and that really ends up in maximizing the possibilities for our customers. We're all about helping our customers solve these big problems. And by giving them these maximum, really turning it up to the max, allows them to get that value. And that's why we think it's a fun name, something easy to remember, and really emphasizes the value that it provides. We've got a lot of great demos here. I think 7 or 8 amazing demos that are showcasing the value of the Max series. CPU that goes generational improvements, doing molecular dynamics with lamps to showcase how much better, 3 times better performance than prior generations. Also, when we bring together some of the workloads with HPC and AI, getting the dense compute there, as well as how the Max GPU can deliver amazing acceleration, 2x better than some of our competitor products in the marketplace today. And then when you bring them together, both the CPU and the GPU Max series, even more. The other great thing I love is not just even the live demos that we have on the showroom floor, but all the customer support that we have. The OEMs with their platforms showcasing how they're deploying those to get those into market, to get those into the end users. Pretty much across every OEM, we've got the support, and it's going to be great to see these systems not just in the Intel booth, but then in their environments as well. Now, we're not the first one to integrate high bandwidth memory in a HPC design. The Fugaku supercomputer, which was #1 for a number of years, had an ARM-based solution with high bandwidth memory, and they saw great performance from that. Now, you talk to them and they say, well, it'll be even more important when they bring it to the x86 ecosystem with a massive amount of software that's already been developed. The workloads that we see that are really critical here are those that are starved when the compute is waiting for that memory to come in. Manufacturing, Earth system modeling. It really is pretty broad energy as well. All those have a lot of demand on memory bandwidth. The other neat thing about it is we have many different modes of operation for high bandwidth memory in the system. You can do only HBM memory, no DDR in the system, which really saves a lot of system cost. You can also use it in a cache mode. And both of those models, you don't do any software changes. You get full performance benefit, 2, 3, 4 times better performance without any code changes. And then we have another mode that allows you to have a lot of system memory and HBM, have to do some code optimization to get the best performance of it, but it gives you that flexibility to go for both broad set of capacity of memory while also getting the benefits of HBM. This has been a multi-year journey. We set out on our XPU path 2017, where we knew that we had to have the highest end CPU, a GPU that was accelerated for the data center, but then also making sure that there was software that brought them together to bring the value of all the Xeon software ecosystem onto the GPU quickly. That's why we started One API in 2018. Started building out the libraries, the language support, making it open standard so others could deploy that on other architectures, all waiting for this moment. And this is really the pinnacle moment here, where we have our CPU, the Max Series CPU, the Max Series GPU, and ongoing support for One API. So this is why this show is so exciting for us, that it's now gone from PowerPoint slides to products in the marketplace, and that's exactly what we love to do. Yeah, another great thing about high bandwidth memory is because you're able to remove some of the system memory, the DDR DIMMs in the system, you can really bring down not only the cost, but also the power consumption. In comparison to a Milan X-based platform, we're seeing 68% less power consumption, achieving the same performance for HPC-G workload. So that drives huge value. We know how much energies cost, not only in the US, but around the world, and we got to continue to drive the efficiency, sustainability that it provides. So it's not just about the performance or cost, but the operational cost as well, driven by lower energy. Yeah, so the other fun thing is Aurora. And the entire Max series is part of it. The CPU, the GPU, and One API are all brought together in the Aurora supercomputer, where we have our production blades being delivered. Every day, another huge shipment is delivered to Aurora. It takes a while to install those, get them fully optimized and configured, so we have a bit of work to do to get that going. But they have their test development system up and operational. It's going to be accessible to the exascale compute program developers very soon, and Rick is going to talk a lot about the value they're already seeing with the stability of the software, the performance that it delivers, and how we're seeing great scalability in that test environment and expecting to do the same for the whole system when we have that in 2023.